Hey everyone, welcome to Neura Pod. This episode is a conversation I had with the BCI guys, Harrison Canning and Colin Fosnot. They make a bunch of high-quality videos about helping people understand the fundamentals of neurotechnology, especially brain-computer interfaces. Hope you enjoy our conversation. I first asked the question, can you guys talk about why you started the BCI guys and what the overall mission is? Here's what they had to say.
The main goal for BCI Guys is to sort of spread awareness of brain-computer interfaces in general. We found that the space is sort of new, and because of that, there's not a lot of content out there related to brain-computer interfaces specifically. So we figured it'd be kind of cool to start a social media sort of company related to specifically brain-computer interfaces and talk about neurotechnology in general, and see where that takes us.
Yeah, so we kind of started this at the beginning of the pandemic to try to figure out a way to provide value to people and get people into neurotech, because before that in 2018, Colin and I started a research group at our school, which Colin has graduated from, Rochester Institute of Technology. And so we were really enjoying bringing in more students and teaching them about neurotech and getting people engaged. And so this was kind of the next thing. And so our big goals really are to create content that's entertaining and engaging in neurotech to bring people in.
Gotcha. Yeah, that's awesome. Like a great mission, because I know that when I was starting Neurapod, I was thinking about how do I inspire as many people and just increase awareness of brain-machine interfaces, brain-computer interfaces. And it's amazing to me. Now I realized it's almost been a year, and I've realized how much this whole space has left to grow. It's like we're still in the total early innings, and there's a bunch of different companies out there that are working on it. And I don't think it's just because I wasn't aware of it before and now I'm paying more attention to it. I think it's partially that, but then it's also literally, okay, this space is growing faster than so many other industries and spaces out there. So it's very cool that you guys are doing this.
Yeah, for sure.
You guys referenced, or Harrison, you referenced that Colin, you graduated, and then Harrison, you're still at RIT?
Yeah, I've got one more semester at RIT. And so
Gotcha.
I'm studying neurotechnology there, and I put it in quotes because it's an individualized major. So I add different components to that. And so primary one is neuroscience, and then business, technology courses, and design. So those kind of all come together into one major.
Yeah, my background at RIT as well, obviously. That's where we met. I was a software engineer at RIT. Like I said earlier, I interned at a company called OpenBCI in 2016, in summer of 2016. That got me interested in all this stuff. Harrison and I started a research group on campus at RIT, specifically centered around brain-computer interfacing. And then I went on to teach a course at RIT for one semester, specifically around like the practical applications of electroencephalography and electromyography, and like using it to do things like drive robots and fun little projects like that, like light LEDs and stuff like that.
I see. And I assume most of the other classmates that you were doing classes with, they were probably not as interested in brain-computer interfaces as you were.
Definitely not. No, I was like I was a little bit of the black sheep in that regard. I'm not trained at all as like a biomedical engineer or anything like that. My background specifically is software and stuff. But yeah, no, it actually started with my interest in all this actually started with a freshman project where we were researching open source projects, and that's how I found out about OpenBCI. That led to me actually asking RIT to buy me a device, an OpenBCI device, which then led to the internship and stuff. So
yeah, and so for me, I'm on the other end of that. So I'm less technical and more, into the neuroscience and stuff like that. But still, I mean, as you alluded to earlier, neurotechnology is still very much in its infancy, and I really believe it's at a breakout point right now, which is why I think it's cool for both of us to be getting into the content space right now to help push that ball forward. But the interesting thing is when you tell people about neurotechnology and controlling things with your mind and all this stuff, like then there's that interest. And so that's what we found with NXT, our research group, was that, you know, people hadn't heard of neurotechnology, but when they saw what we were doing at presentations or stuff like that, they're like, wow, this is cool, and we want to learn about this stuff. And by the end of our first year, we had researchers, about 20 of them, so holding a position, and then 80 people overall that were just like come to our meetings and be interested. And so we were like, wow, like this is an industry that people are going to keep coming into. And so that kind of spawned.
Yeah, it's funny too, because we actually went out to Dubai in was it 2019? Yeah, spring of 2019. And we were talking to like all the kids and stuff. So we were at a maker fair there, which is like a science fair / hackathon type thing. And when we were there, we were showing all these really cool experiments of like moving Mario, right, with just using muscles on your arm, or robotic prosthetics and stuff. And whenever like a little kid would walk up to us, they were like, "Oh, do you have a YouTube channel? You know, we'd love to watch more stuff about this." And that also kind of sparked that interest of like, well, clearly there's interest there. Clearly people think this stuff is cool, but there's not a lot of this stuff on the internet right now. So, yeah.
Gotcha. And now you guys are committed to this full time, right? Or
that's right.
Full-time,
yes.
Air quotes.
Right. Yeah, exactly.
Among my million other projects.
Sure. Yeah.
Yes. No, this is our primary thing right now. But for us to be able to continue to do this full time, we've got to make it sustainable. So trying to figure that
Gotcha.
out.
And then Harrison, I think you mentioned in a last conversation that you have a personal motivation for having studied neurotechnology.
Yeah. So when I was much younger, like younger than 13, I had wanted to be a robotics engineer. I had seen this video of Asimo, which is a robot produced in Japan that could do all these amazing things. I was like, wow, I want to work on that. But in 2012, I was assaulted actually, and I got a really bad concussion. And from that, I couldn't read or write for a year. After that, I had a lot of speaking difficulties, and daily head pain for years after that. And one of the things that went away that I still struggle with a little bit is math, and that's obviously a really important piece to be an engineer. And so I about a year after all this had happened, I was pretty depressed because of the things that I had lost intellectually. And I was remembering this like old robotic suit that I had wanted to design to help people with ALS walk around. But it's like, how do you control that device if someone can't move their body? And I think because of everything that was going on with my head, I was like, I wonder if you could control this stuff with your mind. And so I found some videos of someone actually doing that. And I was like, this is incredible. And my vision of like what the future could be with this technology really expanded into more than just assistive devices, but really changing our interactions, the ways that we interact with technology to make it more human. And so I sort of set this vision of a company that I wanted to create in the future, and then just dove into business, neuroscience, and computer science in high school, just reading everything that I could. And most of my education was informal through that period. And that was how I ended up passing high school, is just from taking neuroscience courses and stuff outside and then bringing that in.
Gotcha. Awesome. Yeah, I think it's important for folks to hear that, background, because it probably helps them like relate to, or not, maybe not personally, but helps them relate to your story, and correlate your story to what you're working on right now. So I think that's great. Yeah,
I mean, it's just been like, this has given me a sense of direction and what I want to do, and just like seeing this future open up of the possibilities of this technology has just been incredible, and it's what has pushed me forward since then. And so I've been fully engrossed in this stuff since about that time, since about 2013, and just loving reading every paper that I can get my hands on.
Yeah. So let's talk about the course that you guys created. It's currently free and posted on YouTube, and you guys are also making other videos on YouTube. So curious about what you guys expect for the direction of the YouTube channel, and then also the other initiatives that you guys are working on.
So for the course specifically, we partnered with Neurotech X to build that course. That'll be live.
A community organization around Neurotech. So they run like student clubs and stuff.
Yeah, they're like the #1 national club for neurotechnology. But yeah, we partnered with them to create Neurotech EDU 2.0, which is sort of a redone version of their Neurotech EDU platform. And yeah, so we're releasing all that content for free. We also have some written content specifically on their platform, which is going to be released here soon. But yeah, the YouTube videos specifically can also be taken as their own course. So you can just move through those YouTube videos and learn the very, very, very fundamentals of brain-computer interfacing, how it works from a neuroscience perspective, along with how it works from like a technological perspective, and then go through the history of it and talk about ethics and have some like morality discussions and stuff as well.
Yeah, so the Foundations of Neurotechnology course was our sort of breakout like first project. And we've been talking about doing this and talking to NeuroTechX for about 2 years now, or started about 2 years ago. And we ended up like in August, we started this effort where, okay, BCI Guys is gonna become a thing and produce the content, and then they'll produce the platform, and then we can kind of put that together. But since it's our content, we put it up on the YouTube channel. That stuff will always be free. And we wanted that to be our first thing, so that there's this foundation of, okay, if people are interested in neurotechnology and want to learn more and actually go into the field, there will always be this course up that they can go back to. But I don't want to say pivoting, because we're always going to make content that's educational, but we're starting to expand our content into something that can reach a more general audience, to try to expand like the scope and the mouth of the funnel for where neurotechnology can reach. And so we have project videos planned where we're doing brain-controlled devices and through applications and stuff, which, Colin, if you want, we can talk about that one main project that we have coming up, but then like YouTube Shorts and then topic videos that are more like focusing on news and stuff like that.
Yeah, we're specifically looking into project-based videos, like Harrison was saying. So I've developed lots of projects with brain-computer interfaces, including robotic prosthetics and like RC cars, things like that, where you can sort of like focus to make a car move forward. You can use your muscles to sort of drive a car, right? So we had a researcher in our research group who literally developed a way to use each arm and contract each arm to basically go right or left and then drive the car forward when they're both going like that. So just little projects like that, including a few other pretty funny ones that we're working on. I don't know how much we want to go into detail on those, but I'm excited for them. We're actually working with somebody like a pretty big brain-computer interface company right now, and getting some really cool hardware to make these videos happen. So super excited.
Nice little teaser there. So it's really unfortunate that like with YouTube, a lot of the non-depth educational the non-depth semi-educational but more entertaining type content gets more views and just appeals to more people. So I'm wondering if there's a way for you guys to make the entertaining content like also educational and layer that with it and just combine them. Is that something you guys are thinking about?
Yeah, that's sort of the goal, is we want to sprinkle in the education with fun stuff as well. Eventually, right now we're leaning more towards that educational piece, because I think when Harrison and I were both starting to learn about brain computer interfacing and neurotechnology, there isn't a lot of easily digestible content out there, like about how brain computer interfaces work. And instead of reading through, I mean, especially as like a freshman in college, it becomes really difficult to convince yourself to sit there and read through all these different scientific papers and try to figure out exactly how it works. So our goal was sort of to ease that burden of education and sort of make it easier for people to just sit down and just watch a video series and sort of get the gist of it without having to, sit there and read through all these scientific papers.
Yeah, and so from that point, we wanted to make it as accessible as possible, because neurotechnology is really intimidating, because it's not just neuroscience, it's also the technology piece, which can mean electrical engineering, software engineering, whatever, all these other things. And so we constructed the videos, we based them off of a model similar to Crash Course, so where we tried to weave in entertaining content. But the point that you were getting at, where core education videos doesn't do as well as pure entertainment videos, and yeah, that's absolutely true, and we kind of knew that going into this. But it doesn't mean that those pure entertainment or closer to pure entertainment videos aren't useful either, because even just introducing the idea of controlling devices with your brain builds awareness, right? And so that can lead people to think about that as a potential solution to future technology problems, or to maybe go down the line and want to engage later. So even if it's something where we're controlling a device with our brain, an RC car or something like that, then like that still can get the ball rolling in someone's mind. You know, it could inspire someone young to look into this more later.
Could not agree more. So you guys referenced that you guys are working with a BCI company. Are there any other companies, or maybe it's that company, that we should really keep an eye on?
Yeah, definitely. So obviously Neuralink is the one that people know of because Elon Musk's name is tied to it, and they are working on some really incredible things. But the industry has been around for a while, although it is like at the tipping point right now. It's been around for a little bit. I know that you spoke to I think it was the CEO from BrainGate a little bit ago, and was it the CEO? Was it? Yeah.
Yeah, I don't think he's Zia, but he is partially associated with BrainGate. Yeah, Dr.
Okay.
John Donahue.
Okay. Yeah.
Yep.
Yeah, so BrainGate has been around for a while, and they're always one to watch because in almost all of the papers of invasive neurotech, like that has been sort of the gold standard that has been used. Although there's a company called Paradromics, which is building an electrode grid that has up to 10,000 electrodes on it. It's a rigid block, so Neuralink devices have a little bit more flexibility, and so that has some benefits, but 10,000 electrodes is way more than previous standards. That BrainGate, I think, gets up to 256. There's another company called Synchron, which is doing a semi-invasive implant. So basically they take an electrode, put it in your chest, and push it up through brain vasculature over the area of the brain that they want to get to, which from my perspective sounds very scary, but it's much safer, and it doesn't require you to actually open the brain, which is a good thing. I'll give you just a couple more. Kernel is kind of the other like really big one in the space in terms of funding. Both Kernel and Neuralink have over 100 million in funding, and they are going the non-invasive route. So they're building this headset built on a technology called magnetoencephalography, which the name of that isn't so important, but basically it's using magnetic fields, sensing magnetic fields that the neurons create to be able to try to determine what it's doing. And so they are putting a lot of money into a different approach. And so, for us that don't have an issue that we might need to get an implant for, that's, going to be more usable in the foreseeable future. And then just quickly, like for devices that people want to get in their hands right now that are being used right now, G-Tech is working on some really cool stuff. They have a bunch of medical hardware, research hardware, and recently the Unicorn headset, which is for like hackers. OpenBCI has a ton of different devices that you can use, and that open part means you can make it for your own projects. Control Labs was bought by Facebook. They do this really cool VR thing where they can monitor the hand in space. And then the last one I'll mention is Cogniaxon. I think that's how you say it. I hope that's how you say it. But they're working on this cool AR platform that's controlled through brain signals, which is just a really smart next step, I think, because having a headset on affords the ability to have electrodes, and they have a really cool version of that. But there are lots of other companies working in that area as well.
Yeah, OpenBCI just partnered with Valve actually to create a VR sort of attachment for the Valve Index, which is super interesting. It's great to see them making progress still because they're really a come up story. You know what I mean? Really awesome to see the progress they've made in the last couple of years.
Gotcha. Harrison, was that the company that you had mentioned right before OpenBCI? The Zoom the recording cut out for a little bit.
Oh, what was I think that was G-Tech.
G-Tech, okay.
Yeah.
Yeah, and their Unicorn headset. Yep.
Gotcha. And then, so kind of to backtrack on some of those companies, with Synchron, that's the one that they have a stentrode. Is that what they call it? Like a stent, but electrode. And then they put it through the veins, and basically anywhere that your veins are, that's where they have a canal to place an electrode.
Essentially, I mean, you need a large enough one that you're not going to clot it and cause a stroke, because that wouldn't be great. But where they primarily go is right up on top of the brain here, because this is an area called the motor cortex up there that controls motor movement. And so their goal, I believe, is to do, it's either, I think it's 100 characters per minute typing, just by having that electrode there, which for context, the best that I've seen right now with an invasive implant is 35, and you have to open the skull for that. So it is a really, really cool technology.
Yeah. And then you mentioned paradromics, which has the 10,000 electrode count. Do you guys believe that the 10,000 is going to be necessary? And then can you also comment on how you guys feel about rigid versus flexible electrode threads or non-threads?
So
Yes.
the more data points you have, the more accurate you're going to be with your data analysis and stuff, potentially, right? So the more electrodes you can fit into a smaller area, the more accurate theoretically your device will be. But there's also issues with like signal processing power and stuff like that can limit the usefulness of larger numbers of electrodes. But especially in implantable devices, it's really important to have a large number of data points. I personally don't like the rigid model as much. So I like the flexible electrodes that Neuralink has been developed way more, because there is issues with like scarring and stuff for these rigid electrode arrays that can create significant problems both from a medical standpoint and from a data collection standpoint, where you can no longer collect data from places that have formed scar tissue. And over time, electrodes can do things like migrate throughout the body and throughout the brain as well. So you got to be really careful with the rigid model. In my opinion, I think the flexible stuff is really revolutionary. I'm excited to see where that goes.
Yeah, I would agree with that last part for sure. That, you know, the ability to avoid blood vessels means that these devices are going to last a lot longer, because scar tissue building up just builds up right around the electrode, makes it not usable after a couple of years. And the other thing that I want to mention is, I think at 10,000 there will still be very useful data that we're pulling from that, because, you know, neurons are extremely small. But you do have diminishing returns when you start putting a lot of electrodes in, because one, if, like, let's say that you are sampling every neuron in a given area, well, having that electrode in there is going to kill some of them. And so now we're getting, you know, null data points from certain things. And so it might actually be better to sample from, let's say, 20 neurons at a point, so that you have that aggregated effect in a certain area. And usually if you're that close, the neuron's function will be similar enough that you can probably get a high degree of you know, usefulness from that. But yeah, for right now, we're still at the point where more electrodes is generally better.
Yeah, to build off of that, I recently saw something that Neuralink had the potential to place more electrodes and threads inside a given area, but they deliberately chose not to, because they felt like the cons outweighed the pros. And so, I mean, I think at some point, like, paradromics may feel the same thing. I haven't done so much research into what they're doing.
You can extrapolate a lot from fewer data points than people would think. And I think that's really where a lot of the innovation is going to be over the next 5 or 10 years, is these algorithms that can sort of guess what's going on with smaller data points. It's obviously a lot easier to convince somebody to get an implant with like 10 electrodes rather than an implant with like 1,000 electrodes. So.
Yeah, and the other thing too, the last thing I'll say on this is, you know, functioning in the brain doesn't happen at any one neuron, right? And so theoretically, if we understood all of the 86 billion neurons that are in our brain and what they're doing, then yeah, you could build a great interface, but that's not reasonable to do. And so consciousness and just doing things with the consciousness and just doing any process that the brain has to do is an emergent property. It's something that happens from multiple things working together. And so, you know, you can often get a good enough idea of what the brain is doing by sampling an area and extrapolating from that.
So it seems like you don't think that it's ever going to be the case where we'll have like a neural cap, where it's like a full brain replacement.
Interesting thought. I actually think that people are going to be more drawn to non-invasive approaches in the near future, at least. So that's things like electroencephalography and electromyography, and those will have more. Um, I think that those are still going to need those large amounts of data points. So like wearing a cap is going to be necessary for a lot of those devices from like an accuracy standpoint, because you need more data points in order to extrapolate what's going on in the brain. Um, I don't know though about so you're specifically talking about like a lace that like sits on top of the cortex, like the cerebral cortex, right? Like the outside of the brain.
Correct. Basically, you cut off the skull portion on the top of your head and just replace that entire thing, and then you have tons of brain data.
I think the biggest limiting factor for neurotechnology is going to be people being scared of it, and I think that especially in the short term is going to be pretty daunting for a lot of people to accept. I bet though in 100 years when people are like when it's super commonplace, I don't think people will care as much anymore, and I think that maybe that'll definitely be something that happens.
Yeah, I think the other thing too is you wouldn't want to have sampling from like everywhere in the brain because it just wouldn't be useful for an interface. So estimates are that about half of your neurons are in the cerebellum, which is a small area at the back of the brain that affects things like balance. Like that wouldn't really be all that useful for an interface. And so you could pick very selective areas, the motor cortex. So really the ones that I would be looking at are the motor cortex and any sensory area to build an interface. So you can affect senses, vision, hearing, whatever it is, and then move something around on the screen. And then maybe the other area would be where it's already being used is like emotional regulation, so helping with mental illness and memory. But other than that, I mean, in terms of the surface area and all the brain areas that we're talking about, this is these are very distinct parts, or maybe the way that they come together isn't distinct, but you can target distinct areas. And so you wouldn't really want to put electrodes across the whole brain. But.
Okay. What are some applications that you guys foresee BCI being most useful for?
So primarily, obviously, accessibility. So helping people who can't move, helping people who are in locked-in states, people with ALS, people who can't move parts of their body. That's where BCIs are going to be the most useful in the near future, and they already have been the most useful there. But also, I think both education and entertainment are going to be revolutionized with brain-computer interfaces. So think things like VR. So imagine you're wearing like a VR headset, and instead of having to move your physical body around in order to move your character or avatar through a virtual world, you can just imagine it. You can just say, or just pretend that you're walking just by thinking about it, and that makes your character move forward. I think within the next 10 to 20 years, that's where a lot of innovation is going to come from. And I think that it's going to be really, really cool. And I'm hoping that we see that really soon, especially with these devices like I was talking about with the OpenBCI headset and stuff. It'd be awesome to not have to be able to like lay in a room and just be in virtual reality and like move your head around without actually moving your head around. So
for me, I've got like two parts that kind of come together. And so the first one is neuromodulation, so a subsect of neurotechnology that is specifically looking to replace or supplement parts of the nervous system that have been damaged in some way. And so I bring this up because this is already the largest and most useful part of neurotechnology, where it can help where you have chronic pain. It can stimulate the neurons to stop them from producing pain signals. And like I said, it's already proven to be effective for mental illness treatments and is used clinically for like Parkinson's and stuff like that. And so these are basically, again, just electrodes that stimulate certain neurons to get them to stop or start sending a signal. And that's already really, really useful because lots and lots of people have chronic pain. I think it's about like a quarter of Americans or something like that have some type of chronic pain. So there's that. So that can be really, really helpful. And then in the future, like far future, talking about brain-computer interfaces, I've always been attached to this idea of making technology more human. So like right now we're typing on a keyboard and using a mouse and looking at a two-dimensional screen. And like, that's really amazing what we can do, but it's not how we naturally interact with the world. We interact in 3D, we're touching things, we're committing emotion to memories, things that we're looking at. And so if we can build an interface that is overlaid into how we interact with the world, I think we can build an interface that's healthier, as opposed to ding notifications and all of this stuff, as long as we build it carefully. And also is just more natural to our state. So instead of looking at a screen, we can feel data, we can get an emotional reaction to data and stuff like that. And as long as we build that carefully, which is, you know, a big problem that we have to be aware of, I think that it can provide a lot of value and be like one of the best technologies humanity has created.
Yeah, very much makes sense. So I have a question here. What do you think makes humans conscious?
Can I take a crack at this first, Colin?
Absolutely.
So, yeah, so there are, yeah, it's a lofty question. It's a tough one, but and you know the answer, like the short answer is that neuroscience has no idea what makes us conscious, and the word consciousness, of course, is just a word that we've come up with. But the way that I think about it is like our ability to, you know, look to self-reflect and realize that we are being, right? And so I kind of break that down into a couple things, components that I would say are part of consciousness that are, and this is probably not all of them, definitely not all of them, but I look at planning. So planning, and that goes in together with understanding of past and future, because most animals are strictly in the present moment, reacting to stimulus. But the higher you see intelligence go, you see more ability to plan. And planning shows an understanding of the past and future, which means that you have to understand your space in the past and future and be able to anticipate or remember certain events and like replay them in your head, as opposed to just have reactionary memory. So that's a big thing. And then I think the other thing is being able to recognize oneself and be like, okay, this is me. So I'm looking at the Zoom call. I obviously know which one is me and which one are you guys. And there are some animals that can do this as well. And so I think that that's really important. And like I said earlier, in terms of understanding, in terms of trying to understand consciousness, individual neurons it's going to be really hard to look at individual neurons and say, okay, this is where consciousness is happening. Because a neuron has no idea what it's doing, right? It's doing a very, very simple task of, I'm going to stimulate other neurons if enough other neurons are stimulating me. And that's all that it's concerned about. Has no idea that it's in a brain that's producing this amazing thing. And so it really is this idea of an emergent property. So some crazy phenomenon that is happening as a result of smaller units working. And one example that I think of with this is ants. Individual ants are not all that smart. They have about 250,000 neurons. Compare that to our 86 billion. There's a lot of ground to make up there. But together, they do some really, really amazing things. Some of them can even farm. They can make these huge things. They can care for the dead. They can do all this stuff. But all that they're doing is reacting to their immediate environment with chemical signals and all that stuff. But they create this amazing thing. And so, but the network of ants is not conscious itself, right? We wouldn't look at that and say that it's conscious. We would say, I think anyway. And so there has to be some answer of the type of organization and the complexity that have to come together to create consciousness. And so there's this researcher, Giuliano Totoni, I think is his name, and he is trying to like put a formula to that. And so he's basically looking at what he does is he looks at people when they're asleep and awake, and people in coma versus awake. And the thing that he finds between these brains is that people who are awake, when they stimulate the brain with electrical pulse, it very rapidly goes out to a lot of different areas. And so there's this, and then starts to like coalesce in those different areas and work on processing. When someone is asleep or in a coma, that signal doesn't get nearly as far. And so one, that shows that there has to be simultaneous processing of multiple things going on. And two, there has to be specialized processing going on in different areas. And so the simplest way to think about that, and I'm almost done because I know that I'm rambling here, but the simplest way to think about that is when we have all sorts of different senses going on, it can be useful to have consciousness and be able to think about this, to where each of these are being processed separately. And there's not necessarily one area where it comes together, but all of it happening contributes to this idea of consciousness. And so I think that having those separate processing areas that are all highly connected creates this perfect formula of where consciousness can arise. Anyway, that was much more than you were probably looking for there. But Colin, if you've got anything to add, go for it.
Yeah.
No, I think it's fine. I mean, Colin, I'll give you a chance. But I just want to make sure with Harrison, like I'm understanding. So you're thinking that there's potentially a formula that could be put to determine one quantifiable way of measuring consciousness in humans also.
Yeah, so that wouldn't tell you like what it's like for someone else to be conscious, but I think that you can determine a level of consciousness by looking at this. At least that's what this researcher is looking into, and I think that his research is promising. So that was Giuliano Totoni, I think is his name. But yeah, and so basically he is trying to make it quantifiable, but I do think that there is some level of, you have to have different things going on at the same time that's highly connected, and that sort of creates consciousness, we think. But like I said, this is a theory. Neuroscience doesn't really know where it comes from, but it's pretty cool that it happens. So
sure.
Oh, and language, I would say, is very important in that as well, because it helps us with the planning, and it really helps us with thinking in the future and in the past. But kind of,
which was something that humans created, though. Like we didn't really have language before. So
right.
It's like, can we create more consciousness?
Yeah, and I think that that's a great point. I think that consciousness is flexible, and I think that with our, like, I think of neurotechnology as a way to advance that consciousness with the access to more information and more processing. Like if we can feel what is going on, there's this guy David Eagleman who I get a lot of these ideas from, and he focuses on sensory substitution. So being able to feel, like to add different senses or to feel things and sense them that you wouldn't normally have a sense. So one of his examples is the stock market. You can give the brain consistent data from something like the stock market or something else, and the brain will start to interpret that. And so you can have a sense that is the stock market. And so I think if we can keep adding senses and the brain is able to handle that, that's sort of expanding on our consciousness, because we have more separate areas of processing that we can add together to create a bigger picture of the world.
Yeah.
Colin, your turn.
I'll be quick. Harrison hit a lot of the points that I was going to say. I think consciousness is an emergent property of sensory information, decision making, genetics, planning, language, all that stuff. So I think that it's not necessarily something that is intended, in air quotes, from like the processes that we use to live and that we use to plan and that we use to do things and plan for future things. I think that it just sort of came about in the process of making more advanced cognitive functions, right? So I think that that's pretty much what consciousness is. Who knows though? could be yeah. Right, could be right on, it could be completely off. You never know. That's the great thing about science, is we're always learning new things. So
sure. Yeah, I just saw earlier today on Twitter, it's like such a crazy thing, but I saw a short video of a spider. It was like a really big spider who saw himself in the mirror, or itself in the mirror, and then it was like starting to dance, and then realized like, oh, that's me, like in the mirror. Right. And you could tell that it's like trying to move to see what the reflection would do. And then it'll like move away from the mirror, or move closer to the mirror, move away from the mirror, and back and forth. Yeah. And then it was like clearly shocked. But I think the fact that it could realize that, I mean, it kind of had to have some sort of consciousness.
Yeah, awareness of self right in there. And so I think, like you said, it's a spectrum. It's been a spectrum throughout human history in terms of creating, or I don't want to put words in your mouth, but like for where you were introducing the topic, it's been a spectrum across human history as our language has developed and our ability to interpret and understand information. But I think it's a spectrum across the animal kingdom as well, in terms of what that means. But
Yeah, it's hard to tell because humans also have a tendency to anthropomorphize. Is that the way you say it?
Yeah,
Where they like,
anthropomorphize, yeah.
yeah, where they we think that something's happening, so that's how we perceive it as happening when it could be some other entirely separate thing that we're not even really thinking about. For example, like when a dog barks at somebody, maybe they're somebody thinks, oh, he's barking to get your attention, when really the dog was barking because he's hungry and you feed him every time he barks. So you got to be careful there, but also, yeah, it's really interesting. I agree with the whole spectrum of consciousness thing for sure.
So how about you, Ryan? We'll turn your difficult
Oh
question
man.
back on you. What is consciousness?
Yeah, I wish I knew. I guess the reason that I asked was because I had started thinking more, like I watched tons of Elon Musk interviews and just
Yeah.
am fascinated by how he thinks. And then similarly, I've started to research Brian Johnson, the guy who started Kernel, and think he's fascinating as well. And the way that he describes what fascinates him about other people is that every single person has their own assumption stack. And so like everybody's world and thinking is built off of their experiences and therefore their assumption stack. And
Yeah.
with Elon, like I think his assumption stack is built off of incredible experiences and lots of real real knowledge that is genuine and well founded. And then the thing that he always is wondering about is like, what is life about? What is consciousness? How do we expand the scope and scale of consciousness? And how do we figure out what the right questions to ask are?
Yeah.
And so, yeah, I mean, I guess I just like, I don't know, but as I've started to learn more about brain machine interfaces and just gotten into, I guess, the nerdier side of all this stuff, I've started realizing like it really is pretty fascinating to know that, okay, humans do have consciousness. I think it's the primary thing that differentiates us from any other species in the world. Like our intelligence is just so
Yeah.
correlated to consciousness. And so
Yeah.
if we can increase our consciousness, then in theory, we can increase our intelligence and vice versa, probably too.
Right. And that's sort of the starting point for everything. And if I were to draw a line between consciousness, I said it's like a spectrum, and I do think that, but the difference between us and really any other animal is just, it's huge in terms of that sort of consciousness stuff, and in terms of what we're able to do with our mind. And that's somewhat obvious. So if I were to draw a line, I would put it there. It would have been interesting to talk to a Neanderthal, though, because they had language and all that stuff, but unfortunately, we'd have to bring somebody back for that to happen. But yeah, I think Elon Musk is really interesting. And the thing that I, so for me, like the thing that like personally drives me is this idea of promoting consciousness and pushing it like farther out into the universe, because I think it's such a beautiful thing that happened on such like it's crazy how it happened, and so beautiful. And it seems like he also like for his own reasons and stuff just has this deep desire to push humanity forward. And that's like, there's a lot of respect for that in whatever he does. So I mean, I think that's really cool.
Okay, so a little bit different. I have a theory that in the future we'll be able to specifically state the portion of any part of the brain. So let's say in the cortex, somatosensory cortex, and then very specifically like this little portion of the somatosensory cortex has X issue, and we'll be able to diagnose and treat like that specific thing. And we won't just say, hey, there's an issue with that specific part. There might be somebody that says we have ALS. Oh, well, that would be more, but let's say like some sort of disease like ALS or Alzheimer's or whichever disease it is, and then we correlate it to a specific part of the brain, then we could say, okay, this person has ALS of this specific part of the brain. This person has ALS of this specific part, and then this person has a different type of ALS. Just like how right now today we think of, well, it doesn't really do a lot of, it's not super helpful to tell somebody, oh, well, X person has cancer. Instead,
Right.
it's much more useful information to say like, okay, well, this person has colon cancer, or this person has eye cancer or prostate cancer. And so in the future, I just think we'll have more detailed information and we'll be able to specifically say, what do you guys think about that theory?
Well, yeah, I mean, I think individualized medicine is the future and will just continue to develop, and it's one of the most important things. And so this is, every diagnosis that we have, I think psychology is specifically a good spot to look. The DSM, which is this collection of all of the diagnoses that can be given for mental illness, mental health, whatever it is, and it like expands exponentially every time it comes out. And the reason for that is not that there are more popping up, but it's that they're trying to make more and more specific designations. There's also the argument that they're trying to sell more medicine, the nefarious one, but let's just focus on the argument that they're trying to make more specific things. Because if you say that someone has depression, well, that can manifest in so many different ways. And so the more specific that we can get is important. But everything that we have right now is just a label, right? And so it'd be really ideal the more data that we can collect. And this is something that Colin and I are interested in personally, and working on something way in the background that's related to this. It's just the more data that you can get around this stuff, the better treatment you can have, obviously. And having biosensing devices in our bodies, around our bodies, can help with that, and make treatment much better.
Yeah, I think that the more data points you have in the brain and throughout the body, the more accurate we're going to get with our diagnoses. So yeah, I'd say in the future we'll definitely be able to pinpoint specifically what's going on, especially if people start getting these implants more commonly.
Have you guys ever done research or thought about or explored gene editing?
I've personally looked into like CRISPR and stuff in the past. I think that over the next 20 to 30 years, we're going to see some really awesome advancements in the way that in those sorts of technologies, gene editing technologies, whether that's designer babies or like the mRNA vaccine, for example, for the coronavirus stuff. Yeah. So very interesting concept for sure.
I'm so here for it. I love it.
Yeah.
I mean, there's like, I'm happy to have an ethical conversation about it all day because there are, issues to talk about, but it's really interesting. And connecting that, not necessarily CRISPR or gene editing, but just genetics to individualized medicine. There's actually a certain type of test, which I've done, called pharmacogenomics testing. And basically what it does is it analyzes your DNA sequence and it helps find medications that will work better for you. And so it basically analyzes this huge database of, okay, like here's someone's genes, here are the medications that they responded well to, here are the ones they didn't respond well to, here are the ones that like they had a neutral reaction to, right? And so it puts you on that and then basically takes all the medications in a category that you could be looking at, and then it helps inform your doctor and make recommendations on a treatment for you. And I personally have found it to be really effective. Previous to this, because this was for like headaches and stuff, had a lot of medications that like I would only get the adverse effects, wouldn't work at all. After this testing was done, like it was the one that was recommended from that worked perfectly. So it's really interesting. Yeah.
That's crazy.
And that's very new too. But it goes into this whole idea of just individualized medicine. And
right.
You have the ethical issues of data collection and all of that stuff that we need to keep an eye on. But the more data we can collect on a person, the better we can treat them and monitor and all that stuff, monitor health.
For sure. Are there any last things that you guys want to share on this video?
Thanks for having us.
Yeah.
We love talking.
Keep doing what you're doing. Yeah, we love this. Yeah. Yeah.
Thank you guys for coming on and having this conversation. I mean, I think what you guys are doing is fantastic, and it's only a matter of time until your guys' growth numbers are really significant. So hopefully yeah, hopefully there are folks who are watching this video that will go over to your channel. I'll make sure to link it down in the description. And yeah, just check out the course that these guys have created. It's really high quality content. And yeah, I haven't watched every single video, but I've watched the vast majority of them. So yeah, highly recommend checking that out. But yeah, thanks for having this conversation, guys.
Thank you. And keep
Yeah,
talking
thanks for
about
the support.
That's the best thing that any of us can do, is just, and even, people watching this too, regardless of what your background is, have, conversations about this stuff with your friends, because it's interesting and it's weird and it's scary and it's exciting, and all of these things together, like this is what's great. And you don't have to be super educated to talk about this stuff. You do to like make policy on it, but that's a different thing. But just talk about it. Like it's, it's really exciting. And that's our number one goal, is just to get more people interested in talking.
And it's definitely the future. It's here to stay, and it's going to keep coming, and it's going to be amazing. So
yes,
for sure.
But we derailed your ending. So thank you very much again for having us on. This is really fun.
You're good. Okay. See you guys. Bye.
Thanks. Bye.
Thanks for listening. Since you've made it this far, we'd greatly appreciate you supporting by liking, subscribing, and following us on all the major social platforms like Twitter, Instagram, and TikTok. And if you really enjoy our videos, please also consider supporting by clicking the join button or going to patreon.com/neuropod. Thanks again, and hope you join us again for the next episode. And last, just a reminder, Neuropod receives no compensation from Neuralink and is not formally affiliated with Neuralink in any way.